Hello, today we are going to compare the Go Zero Yeti 500X that is based on lithium technology in compared to the old trusted Yeti 400 that is using AGM battery, and hopefully you will get the difference between those units and you will get understanding which one you really need. From visual aspect you can see that the lithium version is much smaller, but also it's much more lightweight. You've got absolutely no problem in moving it around. When the AGM version, it is crazy heavy. I would say it got around 1/3 of weight of that unit, so it is significant difference. It is not like a 1 kilogram of difference. We are talking about multiple kilograms, so it is really heavy. From label you know that this unit is going to be offering 500 watt-hour. The old generation is rated at 400. From my real world use case, this unit will never deliver that power at full load. So if you are going to be applying 300 watts load onto inverter, the voltage is going to be dropping much quicker and the device will go into low power cutout mode just because it is not enough capacity to discharge it that heavily. So absolutely forget about that value while using full power. Of course, if you are going to be using USB or the cigarette lighter output, or you will be pulling like 25 watts from the inverter, of course it will deliver that power. On other hand, by the internal resistance, the voltage drop, the Yeti 500X, I would say, will deliver the full promised power through the AC sockets, and I was trying it using my Soldier portable charger. I was discharging it using like 330 watts, so slightly over what it was rated, and I would say it fully delivered that power. It didn't go to any low voltage cutout. The voltage didn't drop just like that after applying inverter. It slowly discharged and nicely show you the time to be fully discharged. On old generation, the only way to recharge it is to use the blue solar input port. From technical standpoint, you could use the side chaining port, and I was using that with my solar system, but that's the only official way to recharge it. And on the latest unit, we've got a solar input port on front. We've got another solar input port on back. And this unit can be also recharged by using the USB-C PD input output. So you can grab a MacBook charger and you can recharge it. This unit contains MPPT, and that one is based on PWM, and I will show you the difference. First, we are going to take a look and do small simulation. Here I've got my power supply. It is set to 20 volt with a 1 amp current limit, and I will attach it to the solar input, and you will see how the PWM is working. If you take a look here, you can see that we are hitting the CC limit, and it is constantly trying to pull the full power. And as you can see, the voltage is settled at 13.9 volt. And from the display, we can learn that we are pushing only 5 watt into the battery. So it is not a pretty efficient system. Now we are going to see exactly the same using the lithium version that's got MPPT. I plug it in. Take a look at the power supply. We are in the CV. We should hit the CC for a moment. We are in the CC. And it should detect that. It backpedal to the CV. We've got 20 volts. And we are pushing 15 watt from the solar input. So as you can see, we've got a couple watts more. for totally free, just by not loading our power supply to the zero. So as you can see, this system is more effective. We can also try the back port and see what's going to happen. Does it also got the MPPT? And it's working absolutely beautiful using the rear port. Just take a look. If you would like to recharge your Goal Zero from AC, then you should use AC power brick. And here we've got device. It is 19 volt, 3 amp, rated at 57 watts. So let me grab my vintage Goal Zero. I will enable the inverter. We go like this. And we are going to be nicely plugging it in. No matter, it can be front, it can be back. We can enable our display. And the MPPT should slowly ramp up until we are going to get the full possible power. And as you can see, we are already around 50 watts, 58. As you can see, it settled around 60 watts. So I would say it is pretty close to the rating of that power brick. Absolutely beautiful. And with the older generation, that's the only way to recharge it. So just imagine that you took it to your friend's house and they do not have charger like this because who have got it, then you will be stranded. But on that unit you can use the USB PD port as input to recharge it or output to recharge some other devices like your MacBook. And let me present you that. Now we are going to be taking a look at the USB-C ports. I've got the Sherpa 100 AC, also from Goal Zero. I really enjoyed that model because we've got two USB-C PD ports and you can configure the direction using software, so it can be either input, output or automatic. I set the first port always as input, second port always as output. And I also love using Thunderbolt cables. I never had any issue with them. First we are going to try to recharge the Sherpa, so I go with the input port. That side go here, and after second we should see the power, and I'm reading 63 watts being pulled out from battery, but of course there will be losses, and that translates to 55 watts arriving at the Sherpa 100 AC. So as you can see, it's working absolutely beautiful, but we can turn it around and I can recharge my Yeti from that Sherpa. So I will be using the output port and going here. And now you are going to be noticing that we are recharging it and we've got 54 watts coming in to that Yeti. And you can see the input port is blinking. So in my personal opinion, this feature is a game changer because you can take this unit into camping, you can take it to your friend's house, and they do not need to have anything from the Goal Zero ecosystem. If they've got USB-C charger, then you can recharge it. Absolutely beautiful. Now we are going to be checking out our cigarette lighter port. That is absolutely beautiful quality. You can see the ceramic insert. We also have got that output that I believe Goal Zero is using on Lightning. So let's grab our powerful hungry light. This is a 55 watts car light. Just take a look. We've got absolutely beautiful. I will enable it and let's see, will it turn on? Just take a look how beautiful it is. I've got feeling that the voltage might be regulated because how bright it is. This is really bright, even with my studio. Let's see what kind of voltage do we've got. We've got 11.7 volt. It is absolutely not 11.7 volts. This is much higher voltage, so let's try to measure it. And here you can see that we are reading 13.3 volt. And that value is not corresponding with the value on battery. So we've got absolutely beautiful regulated 12 volt output. This is absolutely beautiful. It looks like the voltage is going to be staying constant no matter how the battery is being discharged. So it's not that at the end of cycle your device is going to be glowing like a yellow color. You should get a full beautiful brightness through whole discharge cycle. Absolutely beautiful touch. I didn't expect that. In front we've got also two regular USB ports that are rated at 2.4 amps, so most likely like for Android devices. And we've got 18 watt rated quick charge port. We can try to check it out, but I'm not sure if that device is capable of being recharged using the quick charge. So maybe it will go. No, as you can see, we are pulling 16 watts. It was rated 18. So looks like it's working absolutely beautiful. So yes, it accepts the quick charge protocol. And yeah, it's working great. If you take a look here, we've got information how many hours are left until this device is going to be fully discharged. So give it a couple moments to settle, and as long the current and power is going to be staying the same, that value is pretty accurate. I've got my light running, and if you take a look, the output is 57 watts. I can press the units and we've got like a cumulate output. We've got 523 watt hours, and that was my test. We've got the battery voltage 11.7 volts. We've got output 4.9 amps, and we go back to our watts. We can disable screen or enable it. Currently we are displaying 4.7 hours to empty. We can press it and we've got our battery capacity 72%. And this is how it presents. Now it's time to try our beautiful inverter. Here I've got a hair dryer. We are going to be attached it. Of course it is a pure sine wave. Let me enable the output. And we can go into first level. And we are pulling 200 watts, 187 watts. Let me go to the full blow. And we are pulling 300 watts. Here you've got your internal voltage indicator, 11.6 volts. I go to the full burst. We are pulling 300 watts, and just take a look, we are reading 11.3 volts. The capacity indicator is not jumping and it's not making anything stupid. It's just nicely staying as it should be. Let me show you the same thing on the Zero Yeti 400. Here I've got the Zero Yeti 400 that is based on AGM and it's showing a full capacity. I plug it here, I start the inverter, and you can see that we already lost a bar. We go to the first stage and observe this. You see what's happened? The voltage dropped, and now we are at 11 volt, and this is the first stage. I go to the second, full power, 300 watts, and what's happened? The battery is like fully discharged. No, it's not. This is just a voltage drop related to the internal resistance, because the voltage is dropping as soon as we disconnect our load. But this is what you've got with the old AGM generation, so yeah, I don't like it. So let's make a visual inspection. The front panel is made out of metal. This is a metal element. We've got the top plastic, we've got a carrying handle, absolutely beautiful with that weight there is no problem to move it around. We've got a pretty decent cooling, we've got that beefy fan. The back is also made out of metal. And here we've got also another fan. Absolutely beautiful. We can rotate it. On the back we've got the general information about our port. And this is how it presents. Since you know the difference, you could say that you should always go with the Yeti 500X, but in my personal opinion that's not always going to be true. If you can purchase the Zero Yeti used, not working, it is a great buy, and that's because it's using standard AGM battery that you can replace yourself. There is a video on my channel, and with a little bit of effort you can replace the lead acid with lithium iron phosphate drop-in replacement, and basically you can turn it into a really great device. The Yeti 500X is using lithium ion battery that to my eye is custom built. It is a little bit similar to the one you can find on e-bike, but the shape is different, and most likely the only way to repair it is to rebuild yourself and to replace the cells. The cells are standards. I've got a spot welder, I could do that myself, but with 500 watt-hour capacity, most likely I will not play around because there is too much risk involved. There is liability. If the battery tap is going to be broken, fall off, create short, you can create a fire risk. And in my personal opinion, it is not worth the money. I would go and buy genuine replacement if available. But here you can absolutely do that yourself at any time. You can swap it to lithium iron phosphate, and it is just a matter of disconnecting and reconnecting two wires. Lack of modern USB-C and USB quick charge port can be easily overcome by using cigarette lighter adapter. There are small units that can be fit into that socket. So in my personal opinion, this is not the biggest drawback. You can easily overcome it. I would say the biggest disadvantage is lack of ability to recharge it through the USB-C PD. I'm pretty sure that you can think something that is going to be using the side port, but it will be more problematic. So in my personal opinion, if weight is not your concern, if you can buy it cheaply, then the old generation is absolutely fine. For everything else, where the mobility, lightweight and the high power density is your requirement, then the latest one is going to be absolutely the best fit. So thank you very much for watching. I hope you find it interesting. See you next time, and bye bye.